Hello everyone, welcome to our webinar today. So the title is Fixing the Structural Analytical Model in Revit and Syncing with Graitec Advanced Design. So let's go with some slides first, just to do some introduction. Okay, so let's talk about the benefits of this workflow, which is going to be helping you basically to send your models from Revit or even Advanced Steel inside Advanced Design to perform your analysis. So as you see here, the workflow covers both export, import, and synchronization of models between Revit and Advanced Design. The goal is to perform the structural analysis and design of members without, again, remodeling them and remodeling the structure in your structural analysis solution, in this case, Advanced Design. The analysis results and the rebar areas will be transferred in both softwares. So for example, if you have done your analysis in Advanced Design, you can send the results back inside Revit to perform your detailing that we will cover soon. Obviously, this will save some time and avoid mistakes that you can have in models. You can apply different loading scenarios in Advanced Design to the structure, and also you can have advanced analysis sessions, advanced analysis types like seismic, nonlinear, dynamical, etc. inside Advanced Design for the model that you have imported from Autodesk Revit. So how the workflow will work? So I have actually a small graph here. So basically, the workflow works through our GTCX format, which is a specific Graitec format to talk between Autodesk environment and Advanced Design, our structure analysis solution. So normally we start the geometry of a structure. You can start the geometry from either Revit or even Advanced Design. And the workflow is fully flexible. So you can either start from here through GTCX, you can send your model to Advanced Design and perform your analysis. Or you can even start, like if the engineer wants to start the model directly inside Advanced Design has its own UI to create your model. So you can create your model, perform your analysis, and through GTCX, again, send it back inside Revit or Advanced Steel. So through this workflow, all of the loads, even if you have defined some loads in Revit, will be also transferred inside Advanced Design. And talking back from Advanced Design inside Revit, all of the internal forces in your beams and columns and slabs, as well if you have done a concrete design, all of the required rebar areas will be transferred inside Revit. So talking about Revit, we have three main tools in Revit. So power packs, we call them here, to help you with modeling and concrete design and detailing inside Revit. So the first one is, we call it Power Pack Standard. So when you install it, it's going to look like this in your Revit toolbar. And it has different types of usages here. In our webinar today, our focus is going to be first the beam workflow, which we will use the beam connect option, and also fixing and checking your analytical model inside Revit using the Power Pack tools that you see here. So basically, we will see these in action soon. But on top of those, we also have two other Power Packs. So it's called Power Pack Detailing and Power Pack Design, which is mainly based on tools that it's going to help you to create your rebars and rebar cages inside Revit. So as you know, maybe the rebar detailing and design in Revit can take so much time. So that's why the Graitec provides the Power Pack Detailing and Design. And you see it has so many tools here to help you with providing a rebar design and detailing directly inside Revit. So the first option mostly is for detailing, as you see here. So creating main bars, edge reinforcement, splitting rebars, etc. And the other tool, Power Pack Design, is basically based on the internal loads. So it's going to do the design and rebar placement based on the codes that you are using. So basically, we have the localization here, so different country codes that you can select, and based on the forces imported from Advanced Design, in this tool, Power Pack Design, we can perform our rebar detailing based on internal forces, FEM forces coming from Advanced Design. So to give you just an overview of Advanced Design, Advanced Design is a full 3D finite element solution. Okay, so it includes most of international standards. So as you see here, I have just put some screenshots here. So we cover both US codes and Canadian codes, and on top of that, Euro codes with annexes, etc. It is multi-material modeling, so you can have different types of materials inside the same model. So steel, concrete, timber, cold form steel, etc. You can have them all created in the same model. We have automatic load generators in Advanced Design. So to create the snow, wind, even seismic loads, we can create them automatically and apply them to the structure based on the localization that you define and also based on the country code that you are using. The modeling is very simple in Advanced Design. Actually, it follows, the UI is very similar to Revit. And also, you can just create your geometry with just clicking and like a CAD tool, you know. So it's much more easier than other software. You don't need to create nodes first and connect the nodes, etc. It just works with clicking. You click and create your elements. Very powerful mesh engine for very complicated geometry. Obviously, Beam workflow, which is the topic of our webinar today. We have rebar placement and design tools as well inside Advanced Design. In the next slides, I'm going to show those tools as well. So you can do rebar placement and design and even create your drawings for concrete structures directly inside Advanced Design. For steel sections, we have an optimization tool, which is going to give you the best section, which is optimized in terms of cost and weight and etc. And also different types of analysis, nonlinear analysis, pushover analysis, and more that we have in Advanced Design. So here you see some of the models created in Advanced Design. So talking about the UI, this is the UI of Advanced Design. So as you see, I have put this slide here just to show you the UI. It's a fully rendered graphics. We have the project browser here on the left side, so you can access all of the structure and geometry elements, even the loads, combinations, types of analysis, everything here on the project browser. On top here, we have all of the modeling tools. Here on the right side, we have the properties of all of the elements. So that's why I was telling you the UI is very similar to Revit. As you see there, and here at the bottom, we also have user terminal. So you can also type in some values if you prefer. And also here in this terminal, you can see any warnings or errors, etc. So load application. So as you see here, we have different types of loads that you can apply as load cases, dead, live, snow, wind, and etc. based on the country codes. As well, here I have some examples of the automatic wind load generator. So wind on even open structures, as well snow generators and seismic generators, as you see here. And finally, here on the right side, we have the automatic load combination generator in Advanced Design to basically create your combinations and automatically apply all of the required factors to the load cases. Obviously, you can also create your manual loads here. So in this case, I have just created some uniform loads here. So you can have different types of loads, point loads, linear loads, planar loads, etc. So the main difference of Advanced Design maybe with other software is your loads are not directly tied to your geometry. So I can define any type of load as you see here. So I can even create a triangular load, and Advanced Design will automatically mesh the structure, create the nodes, and distribute the load automatically in the structure. So some of the results here. So it's again fully rendered graphics. So this is the deformed shape of this structure. Can check the internal forces as you see there, rebar areas based on concrete design code, and as well you can have the rebar areas in your planar elements like floors or slabs as you see there. So I mentioned rebar detailing is inside Advanced Design. It is possible. So here I have some examples. So this is the foundation. Obviously, the analysis is performed in Advanced Design. So based on the reactions that I have from my model Then I can do my rebar placement directly inside Advanced Design, as you see here. This is a 3D view, plan view, and also in Advanced Design, we can create the full drawings and as well the bar schedule, which is going to help you to accelerate your creating of the drawings and schedules. So this is for foundation, and as well here I have an example of a beam and the column section here, and this is a drawing for a beam. So this module of concrete design and advanced design works for foundations, beams, slabs, and walls as well, including shear walls. So on top of that, as I mentioned earlier, if you want to perform your concrete design and detailing inside Revit, we also have the Power Pack design. Okay, so here I've just put these examples here. So these are the rebar detailing that has been done inside Revit, but using the forces which are coming from Advanced Design, FEM solution. And you just click on calculate after you have the model and the forces inside Revit. You click calculate on our Power Pack design. And as you see here, the Power Pack is able to create all of the rebars inside the elements. And even we have other tools like to create the drawings, etc. Inside Revit. So another example here, this is in our Power Pack detailing, which is regarding the slabs. So the design of slabs also, all of the forces, internal forces, can be imported from Advanced Design. So I will have all of the required bars here. In these are like in Revit, and based on the required rebars, as you see here, I can start by adding my rebars or reinforcements to the slab. So first of all, you can also add different types of mesh and rebar layers to cover that required steel area. And the application of these forces are fully dynamic, so you can just control it with your mouse, diameter of rebars or their distancing to cover the required steel area more economically. And after you created those, you click on OK, and after that, the rebars will be created in Revit as you see there. And our tool will also respect all of the openings, etc. As you see there. Okay, so this was like kind of some introduction on the tools that we have in either Graitec Advanced Design or our Power Packs. So now my colleague Ciara will demonstrate these tools, the workflow, and also the tools that it's going to help you to fix your analytical model and send it to Advanced Design, because it is very important. Your analytical model should be properly created first before sending to Advanced Design and any structural solution, because if you have any discontinuities or offsets or eccentricities that your members are not connected, basically you cannot run a structural analysis on that. So before that, you will need to fix your analytical model inside Revit, which my colleague Ciara will show you right now. Ciara, please, thank you.
Hello everyone. The goal of today's webinar is to highlight the workflow between Revit and Graitec's Advanced Design Analysis software. We're going to cover the simple process of exporting a Revit model to Advanced Design, along with best practices and things that could prevent your model from running in Advanced Design. Graitec also offers powerful tools that integrate with the Revit software to help you perfect your model before exporting. We're also going to cover how to send your model back from Advanced Design to Revit. Advanced Design analyzes structures as a set of nodes and members. If there are discontinuities, the model will not run. Discontinuities can occur in the form of members that do not connect at a node, whether they stop short, go too far, or are slightly off axis and thus also not connected to a node. Graitec's PowerPack tools allow you to quickly fix these inconsistencies in Revit before you export to Advanced Design. The analytical model can be seen by adjusting visibility graphics settings in Revit. Here, I'm going to duplicate the 3D view. I'm going to rename it 3D Analytical. I'm going to go into the Visibility Graphics settings and turn off Show Model Categories in this view. I'm going to go to the Analytical Model Categories tab and ensure that Show Analytical Model Categories in this view is selected. Hit OK, and now you can see just the analytical model. Let's examine an area I know I'm having discontinuity errors. On both the physical 3D model and the level 4 floor plan, everything looks great. I've repeated the process of creating an analytical view for the level 4 floor plan, and I can now see that I have beams that are both too short and too long. This is where PowerPack's Trim and Extend tool comes in handy. In the PowerPack tab, in the Structural section, click the Trim or Extend tool. Select the members that you want to trim or extend, ensuring that you have the multiple checkbox checked. Click Finish, and then select the element that you would like to extend to. Similarly, I'll use the same tool to trim this element here. In the PowerPack tab, in the Structural section, I'll click Trim or Extend. This time I don't need the multiple box checked. I'll select the element, and then I'll select the element that I want it to trim to. The Trim and Extend tool saves so much time, especially when there are a significant number of elements that need trimming or extending. Another useful tool is the PowerPack's Magnetize tool. Here I have a skewed element that needs to be parallel with the grid line. In the Structural section of the PowerPack tab, I'll click the Magnetize tool. I'll uncheck the multiple box since I only have one element. I'll click the element and then select the grid line and click Finish. And again, I'll use the Extend tool to extend the two elements that stop short due to this element being skewed. Another useful tool in the PowerPack is the analytical check. I can set a tolerance, decide what I want to check, run the analytical check, and see that my analytical model is good to go. Free of discontinuities, my Revit model is now ready for export to Advanced Design for analysis. In the PowerPack tab, the BIM Connect tool allows me to create a .gtcx file which can be read by Advanced Design. You can also choose whether or not to automatically launch Advanced Design after exporting the file. I'll hit OK and select a place to save my GTCX file. I'm going to skip material mapping for now and decline generating a report. My GTCX file is now in the folder that I placed it. In the Advanced Design program, I'll click BIM Import and select the file that I just created. It'll prompt me to define materials, and I have the ACI 318 standards here, and I want to define the concrete lightweight 4 KSI material. Here you can enter project notes, project settings, project info. You can also set your units, your characteristics, and how you want your workspace to display. My Revit structure is now in Advanced Design ready for analysis. All of the geometry came over from Revit. As you can see, The foundations that were modeled in Revit came in as supports. I have my concrete columns, my concrete beams and beam systems, my slabs, and my shear walls. At this point, you can add loads and load cases, as well as load combinations, and set your codes for analysis. I've selected the ASC 716 building code as my default for analysis, so Advanced Design has created load cases for me automatically. For simplicity of this demonstration, I'll delete every case except for the dead load case. If I select the dead load case in the Properties panel, I can see that self-weight is automatically included. So again, for simplicity, I'm going to stick with just that loading. Again, in the project browser on the left side of the screen is where I set my load combinations. There's actually a load combination generator, which is really useful. I can select that generator and choose my coefficients, click generate, and it will generate my load combinations. Now, I only have one because for simplicity, I have only chosen to include the self dead weight. So it generated that load combination, but it will generate all the load combinations for live, snow, wind, etc. With my loads and load combinations generated, I'm now ready for analysis. So again, in the project browser, there's the analysis tool right here. I'm wanting to perform a reinforced concrete calculation, so I'm going to select RC calculation and hit OK. The program will also let me know if there are any warnings and instabilities. As you can see, there's quite a few here. So I've got some warnings, which I can ignore, but I also have some instabilities, which I need to figure out in order to get Advanced Design to analyze this structure. Upon further investigation of my instabilities, I've scanned around the model and I can see a few issues. I've got these members out here that are kind of off in space and not connected to anything. This mesh here is my slab, and this level is my girders and beams. And there's obviously something wrong here. This is a great opportunity for me to send the model back to Revit and fix the analytical model and bring it back into Advanced Design so I can continue my analysis. Back in Revit, I can see a similar issue. When I looked at my model from the XY plane, everything looked fine. But what I missed was in the Z direction. There's some sort of issue there. You can really see it in this elevation view. I've fixed my Z offset issues, and now I have a fully connected model. So again, using the BIM interoperability tools, I was able to send my model back into AD again and rerun the analysis. And I'm no longer getting my warnings and instability errors. I can go up here to the results tab, go to post-processing and see my deformed structure. It's got this gauge here to show what the deflections are. I can toggle between displacements and my internal forces. In the linear elements section, I can see my forces in the X direction, Y direction, Z direction, and just generally toggle between whatever results I need to see for analysis. I can also launch the RC calculation. in the RC Design Results section of the Results tab, I can look at buckling in the LFY direction, look at post-processing, and I can see which members are failing based on this criteria. I can also take a look at things like reinforcement. I can look at my minimum area of steel required, go to post-processing, and I can see how much steel is required based on the cross-section. Okay, so now I'm going to go back to the model, and let's say based on my results, I want to change the size of one of these columns. I'm going to use this column, for example, and change its size to a 30 by 24. Now that I've updated this column, I can export the Advanced Design model as a GTCX and bring it back into Revit, and Revit will recognize the change that I've made in this column. Back on the Revit side of things, I'm going to go in the PowerPack tab and go to the BIM interoperability tools, and I'm going to choose synchronization. I'll go ahead and select the GTCX file that I just created, and it'll show me a list of every single change that was made in AD. So I'm going to scroll down until I see my column change. Here it is. I changed the type of this column. I want to accept that change. Hit OK. Yes, I want to apply the changes. No, I don't need to see the report. And that size is now updated to a 24 by 30. One other thing that I wanted to point out in the PowerPack tab in the BIM interoperability tools, if I had chosen import, this is a great way to import things from Advanced Design using a GTCX file whenever I have nothing in my Revit file, or if I'm starting a Revit file from scratch where I had modeled it first in AD, I can use this import tool to pull all of the geometry from AD into Revit from scratch. So as you can see, the interoperability between Advanced Design and Revit allows you to work seamlessly between both programs. You can make changes in either program and exchange information back and forth, saving you hours in productivity.
Okay, thank you very much, Ciara, for your demonstration, and thanks to you all for attending this webinar. So just to let you know, if you have any questions, you need more information, or you even want to give it a try and try these tools, you can always send a request to our support, so support.us@graitec.com or support.canada@graitec.com. So let's go with some questions. So if you have any questions, please type them in the chat tool of the platform, and we are going to answer them now. Thank you.